In this video, we'll look at functional groups that can be found within organic molecules. So although organic compounds are made primarily from the same atoms, carbon, hydrogen, oxygen, and nitrogen, they can have very diverse functions, and this is due to the way those atoms are connected. And that leads to the presence of functional groups within the organic compound. So a functional group is a small group of atoms contained within a larger molecule that impart characteristic physical and chemical properties. So the presence of the functional group gives you a clue as to the properties of that molecule. So we're going to look at examples of the most common functional groups. You've already been introduced to two of them. The alkene, which is this carbon double bonded to another carbon, and the alkyne, which is carbon triple bonded to another carbon. And so when these groups are present, the molecule becomes a bit more reactive and it is able to undergo addition reactions that we looked at in the last lesson. When you get other functional groups added to a hydrocarbon, what you get are hydrocarbon derivatives, because you start getting atoms other than carbon or hydrogen in your molecule. So there are single bonded functional groups, and then we'll look at a group of functional groups that have a double bond. So the first one is the alcohol group. So this is an OH, which is bonded to any hydrocarbon chain. The next one is the ether, and in this situation, the oxygen is single bonded in between two hydrocarbon chains. And then finally, the amine group is where you have a nitrogen single bonded to a hydrocarbon chain, and nitrogen wants to have 3 bonds, and so one of them will go to the hydrocarbon chain, and then the other two could either be to a hydrogen or to other hydrocarbon chains. So that's the first group of functional groups. The next group we're going to look at all contain a carbon double bonded to an oxygen. And that configuration, the carbon double bonded to an oxygen, is called the carbonyl group, and it forms the basis of a series of different functional groups. So the first is the aldehyde group, where you've got a hydrocarbon chain, which is then bonded to the carbon, double bond to the oxygen, and then there's a hydrogen. So this effectively ends the molecule. Okay, so it's found at the end of molecules. Whereas the ketone, the carbonyl group, the C double bond O, is found in the middle of two hydrocarbon chains. The next one, carboxylic acid, you've got the hydrocarbon chain bonded to the carbon, double bonded to the oxygen, and then the carbon is also bonded to a OH group, the alcohol group, creating a carboxylic acid. The next one is the ester. So this is very similar to the carboxylic acid, except that the terminal hydrogen has been removed and another hydrocarbon chain is added. So you've got a C double bond O and then a single bond O in the middle of two hydrocarbon chains. And finally, the amide group, which has that C double bond O, which is then bonded to a nitrogen, which then is bonded to either hydrogens or hydrocarbon chains. So those are the different functional groups. And all of those groups that we looked at, except for the alkene and the alkyne, they introduce a more electronegative atom into the organic molecule. And we've talked about how hydrocarbons are nonpolar because they have only carbon, carbon, and carbon-hydrogen bonds. But once we add in that electronegative atom, we now get a polar bond, creating a polar molecule. And so because there's polar bonds, These molecules can have dipole-dipole interactions between them. So they have stronger intermolecular interactions. And what that means is that molecules with these functional groups will have higher melting or boiling points than their corresponding hydrocarbons because their intermolecular interactions are stronger and harder to break. In addition, the presence of the polar bonds will allow these molecules to better dissolve in other polar molecules, such as water. So hydrocarbons are generally nonpolar. They will only dissolve in other nonpolar substances. Once you have these functional groups present, the molecule then is better able to dissolve in other polar molecules like water. So there you have the different functional groups and their effect on the molecule.